Okay, 2.1. Introduction to the functions. There are two definitions we want to touch on. The first one is what a relation is. Now, a relation is just any set of ordered pairs. And what I mean by an ordered pair is an x value paired up with a y value. Okay? A relation could be any of those. Any ordered pair falls into the realm of a relation. It says in a mathematical concept, it is where the ordered pair consists of real numbers, and the ordered pair, of course, would be x, y. The domain is all the x values. Once again, should be a review. The range refers to all your y values of a particular relation. Now, a function is a special type of relation, okay, in which each member of the domain, so each member of x, is paired with a specific member of y. They cannot repeat. And this should bring back some memories of Math A30 with your one-to-ones, your one-to-manys, or your many-to-one. Okay, that should be kind of jumping back into your mind. A function could be of the form, let's say, 4 and 6, or 3 and 5. Anything that does not have something like that. 4 and 7 would not create a function here, because if you look at this x domain value, it's got a certain value of y, and at 6 in this point, the same domain here has a different range. So that is not part of a function. That would not represent a function. This would be a relation. But if this were to not be there, that would signify a function. And what that says here is every x value can be paired with one and only one y value. Okay. Function notation. Functions are named by lowercase letters such as f, g, or h, any letter. They typically don't have an x as the beginning or a y as the beginning letter. That would tend to somewhat confuse students, I think. So we use typically other letters other than x and y. So if we were going to name a function f, we could call it y is equal to f of x, and then it's read, f of x is read f of x. Okay. Now, here's our first example. If I've got a function f of x is equal to x squared, remember this is the same as having y is equal to x squared. F of x is kind of taking the place of that. Okay, they're the same function. This function that I'm circling in green here right now is specific, and it tells me that it is a function because it's written in function notation. So f of x is equal to x squared. If x is equal to 5, what we simply do is we plug in 5 in for our right-hand side of our function. So f of 5 is equal to 5 squared, or f of 5 is equal to 25. Now, if you were looking for the ordered pair, you knew x was equal to 5 because that was what was given in the question. So when x is 5, our range is the value that we have attained by plugging it in. So if you were asked for the ordered pair, you write 5 as your domain, and your range would be 25. Shouldn't be anything new. Let's move on. Here's where I want you guys to do a little bit of work for me, please. I've given you a function there of 6x minus x squared, and I would like you to find f of negative 3 for me, please. So if you would just do that on some scrap paper, that would be great. All right, let's take a look at the work here. So I plug in f of negative 3. It's going to be 6 times negative 3 minus negative 3 all squared. Hopefully we didn't get caught off guard with that negative 3 squared. That negative 3 squared becomes positive 9. With the negative sign multiplied onto it, it still remains it's minus 9. So I've got negative 18, subtract 9, negative 27 as my y value. So if you were to write out the ordered pair, we've got -3 and 27. It's not supposed to be positive. Just a typo. I'm not sure why he's got this here, so let's just ignore this for a second. I want you to find f of a using the same particular function. It's not a whole bunch to do here, but we're going to use the same f of x. I want you to write f of a instead of f of a number. Still plug in the same particular value for whatever you're plugging in for x. It doesn't have to be an integer though. It can be a letter. And it's going to lead us into something on the next slide. It is as simple as you might think. Okay, we're just going to plug in a wherever we see x. So it's 6 times a minus a squared. I've got f of a is equal to 6a minus a squared. And I understand that might seem very elementary, but it is going to play a role when we get into this next slide here. This is leading us into something that you will find, you'll see a lot of when we get into chapter 3 with derivatives. It's looks very complicated, but here's what I'm asking us to find. We're still using the same function, 6x minus x squared, but what I'm asking you to plug in is a couple of things. What I highlighted in yellow there is kind of what we're going to be doing here with function. There's going to be some operations involved because there's two things that they're being asked to plug values in for. The first thing I want you to plug in wherever you see x is something that I'm going to ask for. It's called x plus h. Okay? So that's the first thing I want you to do. I want you to just pretend this question said, find f of x plus h using your function f of x. So last question you plugged in a. That was pretty simple. Now I want you to plug in x plus h, wherever you see x. Bailey, you okay with this? Yeah. It's nothing different than plugging in a number. Let's say if I actually plug in 3. You plug in 3 wherever you see it, wherever you saw x. But now I'm asking you to plug in x plus h, wherever you see x. And yes, you might have to FOIL something here. Alana, can you help me out with the red portion of our question?
Mr. Johnson,
Hold on one second. Excuse me. Yes.
what is your golden key for the calculus noodle?
Who's asking?
Mr. Holt?
Why does he want in?
Because he's got a student that thinks it's enrolling.
Oh, really? Okay, it's Baldwin.
Sorry?
Baldwin.
That's it, Tony?
Yes, all lowercase.
Okay.
Sorry about that. Okay, Alana, what did you have for when you plugged in x plus h? No, I wanted you to plug it into this function here.
Oh, so like x plus b like that?
What is it equal to?
6 times x plus minus x plus h squared.
Now I want you to simplify this as much as you can. So let's distribute the 6 on. What would I get?
6x plus 7h.
Minus. I need to simplify that. I'm going to use brackets. So what is x plus h squared?
X squared minus 2h minus x
X squared
squared.
minus 2xh minus,
Oh.
sorry, plus h squared, yes?
How's that minus?
It's not, it's supposed to be plus. You just didn't see that clearly, okay, but that's okay. Sure. Now I'm going to distribute that negative sign. Can I simplify any like terms here? Do we see anything that looks similar? We don't? Great. Now, I'm going to color coordinate this. I'm getting to, I'm taking the long road, so to speak, to find this answer, because the entire question is solving for the whole thing. All I've done is the part in red. I need to now do the part in green if I didn't go down too far. So I need to do the green part. I need to find what f of x is. So f of x is quite simple. What do you think f of x is equal to, Taryn?
That just the 6 or I mean, just
I'm plugging in x wherever I see x over here. I'm not trying to trick us. It's as easy as you probably thought the first time. I just leave it. It's the same. It's 6x minus x squared. Okay? And there's nothing really to do there. Right? The blue part, does it ask me to plug in anything for the blue? Is it f of h? You see written f of h anywhere? No. Okay, so what that means is you're just going to put your red subtracting your green all over an h. So I need to look at my red first, and this is what we got a value for the red part that corresponds to that particular area. And then I'm going to subtract my green and put it all over h. So let's look at what that's going to look like. So it's red minus green. So I'm going to write red 6x plus 6h minus x squared minus 2xh plus h squared minus, and we're going to use brackets because, you have a question, Lana?
Plus h squared.
It's not supposed to be. I'm having a good time here too. Minus h squared. Let me erase this too. Alright, now in green I'm going to use brackets like I was mentioning before. And some of you I know are of the super awesome mathematical mind, might not take this many steps, but I'm going slow on the first one. I'm going to just continue to simplify here. I know it seems like a waste of time to rewrite all these steps, but sometimes it's nice to have them so that we don't go too fast and try to make too many mistakes. And this is all over h. Now I'm going to ask you if there are any like terms to combine. And I think your answer will be different now that we've incorporated that green portion of our question. Can anything cancel?
X squares.
X squares can cancel, Bailey says. So this is going to go away with that one. And the 6x will go away. Is there anything else that can be eliminated? Just don't get too far ahead of me. You're thinking. That's good though. Let's write out what's left. Okay? I know some of you might have been thinking ahead like Taryn is. So here's what I have so far. I think I have that. Yep. Now, is there something I can do to the numerator? Taryn, take an h out of all of them. Good. So I'm left with h. What's left? 6 minus 2x minus h all over h. Can I cancel those h's now? You bet, because it's multiplication happening now. So they're gone. What am I left with? Can I do anything else with that? No.
I have a good sound for it.
Yes. They have probably installed it. Do you guys have any questions with this particular question here? Silence from the other end, is that good then? Don't buzz in if you don't need to. Awesome. Now, this might seem like a strange question, a very strange question, but you will see this type of question in abundance, if that's a good word, coming up in calculus. This is basically the idea behind, it's called the fundamental theorem of derivatives, plugging in this f of x plus h minus f of x all over h. You'll be doing this repeatedly throughout the course until we get into chapter 5. But you'll see. Now, this graph, if you're far away from the smartboard, you might want to move a little bit closer so that you can look off the graph when we get to this this question here. So in red here, I know there's no red yet, but you'll see it up here, is f of x. No, it's not, it's g of x. But same idea. It doesn't really matter what the name of it is. I'm asking to find g of negative 3. Okay, so because this is g of x, and I'm asking to find g of negative 3, you can see that x has been replaced by negative 3. So what I need to do, and this is somewhat confusing for some, but somewhat very simple and obvious to others. Because x is negative 3, I need to go on the x-axis to where negative 3 is. And I need to find what its coordinate or what its corresponding y value would be. So if I look at negative 3 here, okay, I don't physically go to the negative 3 on the axis, but I go to negative 3 on the axis and go up or down to where my function is found. And I can see here that when x is negative 3, my y value is 1. So you would say g of negative 3 is equal to 1. Let me ask you another question. It's not on here on these notes, so you're going to have to maybe figure this one out. And maybe I'll ask Etonia to come and on your smartboard, I want you to find g of 3. Could you, Etonia, go up to the smartboard, put a little dot on the portion of our function that that corresponds to, and then fill in the answer for us, please? We get the dot in the right spot. Excellent. Negative 1. Okay? Now, I don't think we'll probably need to do any more. This is a review from 8:30. The only other option is if I gave you the opposite type of operation. Now, in black over here, I'm looking for g of x is equal to 3. Now, in this case, what are you given? You're given the y, and you're looking for x. You can physically see it's nice. Oh, I'm looking for x. So now you start on your y-axis and go to where 3 is. Okay? So I've got 3, and you might have more than 1. Okay? So when I go to 3, I've got a point there, and I've also got a point just to the right of that asymptote line. Now, what is x value from our first dot? So -4. When morphed into the circle there. And over here, it's about 2.2. I guess I say 2.2, so that was also. So you'd have 2 answers there. You could have more. Right? Don't always think there's only going to be one answer. Like I said, review. I want to give time to work on it so we don't have any homework and we're fresh and ready to go for tomorrow. There's the assignment 1 to 10 odds. On numbers 3, okay, I just want to give you a little forewarning. You might need to remember your unit circle. And I maybe will get a unit circle up there for you, and then you'll have it fresh for you. They will be involving some circular functions on question 3. But don't get too stressed out. I'm sure we can handle it. But I'll try to get this one up there. I'm just going to come back for a second here. So there's a unit circle for you to use for question 3. Any questions, guys? Just don't hesitate to buzz in. And yeah, good luck. I'll check in with you guys in a little bit here. Alana,
Yeah.
can you do me a favor? Could you go to the smart board, click on that smart recorder and push stop?
Okay.